In this video, we'll be diving deep into important features of platform.io, such as utilizing the same project for multiple environments and boards in the same framework of ESP-IDF, then tuning the clock speeds, upload speeds, and serial monitor speeds. It's all by using platform.ini file, which is the configuration file. I'll also explain two bonus power tips for platform.ini at the end of the video to improve the readability and make you feel like a pro. So stay tuned until the end of this video. In the previous video, we have seen how to set up ESP-IDF in platform.io, and if you haven't watched it yet, you can watch it from the top right corner or from the description. Hello everyone, welcome to IoT Frontier. My name is Hariharnath. Let's get started. So first, we'll open Visual Studio Code, and then we'll look into one example, and then we'll look into various sections of platform.ini and understand its features. So first, you can go to the platform.io. So if you click on it, it will initialize, and then you can click on this PIO home open, so that the PIO, that is platform.io homepage, will be open. So here you can search for project examples, and from here you can search for ESP-IDF hello world. So select this and import. So if it is first time for ESP-IDF, then it will take 5 to 10 minutes. But if you have already previously used ESP-IDF in platform.io, then it will not take much time. So now this workspace and the project has been opened, and immediately it will also open multiple things in the bottom which are not even related to platform.io but were related to ESP-IDF that we have installed previously with VS Code. So you can ignore those and also close this ESP-IDF welcome page and concentrate on this platform.ini. So first we can see the platform.ini is located under the root folder, and this code, if you directly look for the source code src hello world main.c, so you can see this is just printing some important features and the chipset about ESP32 or the board that we are running. So it will tell us what are the features it has, like Bluetooth, BLE, and silicon revision, flash size, etc. So all these things will be printed and we can monitor them via serial monitor. Now let's look into the platform.io.ini. So here you can see various things. So to stop confusing, so I'll first make it simple and remove everything else so that it won't be confusion for you. Here if you see, this is env, which means that environment, and you can give any unique name here, that is ESP32 dev, or you can give dev1 or some kind of user friendly names here. And here in the board you can mention ESP32 dev. So this board has to be in a standard naming format. So those things can be found in the documentation from this link. And the platform is ESP32. Framework that we are using is ESP-IDF. So in the previous examples or the previous video, you might have also seen Arduino, and the monitor speed right now is 115200. So this also I'll try to keep it as it is, and then we'll explain you later. So now if we try to run this, we'll check what happens. So first, to run this, I'll just connect my ESP32 board to the computer. So I have connected my USB, and then we can go back to the platform.io, and here based on the environment you will be having default ESP32 dev, etc. And if you want to select a particular environment and not worry about other environments, you can click on this. So it will say switch project environment. So click on this. Instead of default, you can select ESP32 dev, so that the project task also got updated and we can only see related to ESP32 dev. Once this is done, you need to wait for this metadata, and whatever is loading, we have to wait until that, and then only we have to start. So once this is done, we can click on build. So for the first time, it will take nearly 2 to 3 minutes to do all the build based on the size of the project. So now you can see the ESP32 image has been created, and we can see the success message, and it took 44 seconds to complete the build. And after this, you can just click on upload and monitor. so that it will upload into your ESP32. You can see the 115200, that is the monitor speed that we have set, and also I'll show you how to unset this and what happens if we don't provide this monitor speed in the next section. So right now we can see the COM3 is used for this 115200 and the baud rate etc, everything is mentioned. And after that we can see the SPI flash size of 4 MB, and you can also see the partition table for NVS, physical init and factory, and other segments also of the partition table, and here also we can see all the things. And later on you can see CPU frequency is 160 megahertz, and the project name is hello world app version, ESP-IDF version, and RAM details, allocation, and also we can see whether it has 2 CPU cores and Wi-Fi, BT, BLE, everything is mentioned here. And then it will restart after 10 seconds and then again show the same thing in the serial monitor. So because we have clicked upload and monitor, it has automatically opened the monitor screen. But if you have only uploaded previously and wanted to monitor, you can click on this monitor. And if you try to click on monitor for the second time, you will see that a permission error comes because you are already monitoring with one COM port, so it will not allow. So you can just close that. So let me now explain you what happens if you don't explicitly mention this monitor speed. So what I can do is I can just provide this as a comment. So it will automatically save and update the metadata. So once this is loaded, we can see in the project's task and we can try to build, upload and monitor. So I'll simply click on upload and monitor because it has detected there is some changes happened. So I can click on upload and monitor. So it will try to build again. So you can see it is directly compiling because there is a change in the code. So I don't have to explicitly build again. So here you can see it has created the ESP32 image and then it will start uploading. So once this upload is done, it is starting the monitor, the serial monitor. You can see all the garbage values are being shown because we haven't set this monitor speed, because it has already taken the default monitoring speed that is called 9600 baud rate. But 9600 is not the baud rate that we are looking for this in ESP32. So we want to look into 115200. So that's why we have to provide this explicitly so that we can read as the previous example where we can see all the details of ESP32 chip. So that is the importance of monitor speed. Next thing is we can create another environment. So I'll try to create another environment with low speed. So I just copied everything as it is and then created something called ESP32 dev low speed. So for this, what I can do, in the previous example we might have seen the CPU speed. So in that we understood it was 160 megahertz is the clock frequency. But if I want to run half of that, so here we can provide 80 megahertz, means 80 into 10 power 6. So that many zeros, and then this is a long integer, that's why L. So we need to provide this so that we can make another environment where the clock frequency will be lower. So now if I want to select this as a project environment, I need to again go here and click on this low speed, and then it will automatically update the metadata and the exact project task will be shown here. Now you can see the project task for this low speed. And for example, if you don't want to see the low speed ESP32 specific here, so you can just click on the default one here and you can see both of them here and you can select them individually from here. So you can build from here also. So now I'll try to keep it default and try to build specifically. So now click on this build. Now we can see it has successfully built without error. So I can click on upload and monitor. Now you can see again the same things are being repeated. So it's not only about the CPU frequency, but if you want to keep another environment with a different upload speed, so I can put high speed or high upload speed as another environment. And here what I'll do is, so I'll just remove this and provide upload speed is equal to 921600. So generally the upload speed could be equals to this monitor speed, or it could be 9600 or something, which is the default one for the ESP32. But now I'm forcing it to be this 921600. So let's see that. So I can just click on this high upload speed and wait for until it is loaded. Now I can simply click on upload and monitor so that it will build automatically. And be cautious that this upload speed of higher speeds might not be supported by your board or the wire that we are using. So this has to be used with caution. And now again we can see everything is working normally, and the build speed and upload speed was just 2.2 seconds. So let's try to see with the normal speed what happens. So I'll go to ESP32 dev and try to click on upload and monitor. Now you can observe that it was using 2.8 seconds. So it is somewhat slower than the 2.2 seconds that with the highest speed we have tried to use, and remaining things are same. So these are the some of the tweaks that we can do with this different environments of the same board or different board. Now we'll try to do the different board. So I'll just copy the default one and create a new board, that is ESP32-S3, and here also ESP32-S3-devkit C1, and I'll keep everything as it is, that is ESP32 and ESP-IDF, monitor speed, everything is same. And once you start using this new board, and which has never been mentioned in this platform.io, then it will try to download the toolchain. That might take some minutes, so that you have to wait patiently until that is downloaded. So until that, you might see some loading page shown here in the notification. Once everything is loaded properly, you can simply click on upload. So now I'll try to shift from ESP32 to the ESP32S3. So I'm changing my USB. So I've connected to ESP32S3. Now I go back here and wait for it to be completely loaded. So now it has been loaded. I'll just click on upload and monitor so that it will build automatically. So I was getting these errors because I was trying to connect to the USB port of ESP32S3. Now I have connected to UART, and let's see if it works. Now you can see it is automatically writing, and because of the wrong port I have used, it was showing this kind of error. So here we can see something about this board. It is again using 115200 and all the different bootloaders. We can also see Wi-Fi data, partitions. So this is having Wi-Fi BLE kind of thing, and you can see 8 MB external flash. Those things are mentioned here. So this is how you can use same project for different environment as well as different board. So now let's talk about platformio.ini, that is the project configuration file that we have been looking, and what are the different examples we can find. So here we can see this is the documentation page you can go through, and here you can find multiple different examples and different sections as well, and what each section looks like we can look here. And from the left side you can see generic options, and this is platform.io specific, and something about the section about environment, the common as well as working, etc. Everything can be seen here. So now come to the bonus part. Until now we have used everything in a separate environment, and all the parameters are mentioned for each of the environment. What if we have something common? For example, we have platform and framework and monitor speed, all of them as a common thing, and remaining will be different, right? So what we can do is we can just use something called env. So this will be as a master copy for the configuration, wherein we don't have to mention anything in the below of them because it will be inherited from here. So this is like a global variables. So for example, here I don't have anything other than board, and other places also I can remove that. So it will work fine. And for example, here I want to keep this monitor speed as 9600, then this global variable or the parameter cannot override this. So local variable will be used in this case of S3. So this is how it works for the environment. So this is one of the pro tip that you can use so that it is more usable and inheriting some of the features and keep it simple. And the second thing that we can talk about is the common. So for example, you have different set of boards. For example, you have STM32 and ESP32 boards. In that condition, you don't want to use something from the ENV. You want to use something common, which is like a user defined variables. So what you can do is you can use like this. So you can mention common and mention as a project version and different shared variables you want to use in it. So you can use like this. So here you can see this common will not be understood by platformio.ini. This is very much custom as well as user defined. So whatever you want to use, you can use here. So what I have done is project version and then build flags. And for the version, I can use something like and dollar with the bracket of common dot project version to read this. And then we'll get everything in this, and then debug level is 1. So this is how you can use it. And for example, if you want to use this shared build flag, then also you can directly use it, like in the S3 if I want to use that. So I can write build flags is equal to this dollar and common dot shared build flags, so that it will read from that piece. So this is how you can use some of the pro features of platform.ini and look like a simplified and pro version. And that's all for this video. If you found this video informative, please type helpful and smash that like button. In the next video, I'll explain how platform.io manages libraries automatically with a practical example. So stay tuned for more videos. Your support means a lot to us and helps us keep creating more content like this. So please subscribe to the channel and hit the bell icon. Thank you for watching, and I'll see you in another interesting video.